Hey guys, welcome to 4.5, another kind of substitution. So, in the AP exam, you're going to find out that there's going to be some integrals where you cannot use your traditional U substitution. So, if you remember in the past videos, I did talk about like you can use U substitution by letting the inside equal U, and this will work 99% of the times. Today, we're going to be discussing that 1% that doesn't work. So, not always will U substitution work. For example, if I was a student and I thought that, oh, I can do this pretty easily, let u equal the inside. Du is equal to 2 dx, and then I have a problem. I have a dx. The 2 is no problem, I can divide the 2, but I'm missing an x to replace with. And I can see that letting 2x minus 1 equal u is a mistake, which I can probably let u equal x. Maybe the other one might work. Du equals dx. Well, what about the square root of x? That cannot be replaced with anything. So I noticed that u sub doesn't work like the way I taught you. And you're probably thinking he lied to us. Well, here is the 1% where u sub doesn't work. How do we do this? We're going to let u equal 2x minus 1. This is another kind of u substitution. Okay? I like to call it x substitution. X sub. Because you're going to see what we're going to do here. Instead of letting u equal 2x minus 1, I'm sorry, let u equal 2x minus 1, but instead of letting it solve for you, letting it be solved for you, solve for x. What does that mean? It means I have to add 1 and then divide everything by 2. So let me do this step at a time. U plus 1 equals 2x. If I add 1 to both sides, I get u plus 1 equals 2x. If I divide by 2, I get u plus 1 over 2 equals x. So I'm going to do an x substitution now. For every x, I'm going to replace it with a u plus 1 over 2. Watch carefully. This x becomes this x, which is equal to u plus 1 over 2. The square root of 2 u plus 1 over 2 minus 1 du. Now I can cancel out those 2's so that it becomes u plus 1 over 2, the square root of u plus 1 minus 1 du. Well, plus 1 minus 1 goes away, so I really just have u plus 1 over 2 times the square root of u. And remember that constants can be moved to the front, so I can rewrite this integral as 1/2 u plus 1, and instead of square root of u, I'm going to write it as u to the half du. Now this looks a little bit more easier to integrate. Let's just distribute the u to the half into the u and into the 1. The integral, what is u times u to the half? That becomes a u to the 3 halves. A u to the half times 1 is u to the half. So, and then integrating with respect to u. Now we can go ahead and integrate this as we normally do. U to the half, what's the integral of u to the 3 halves? It becomes u to the 5 halves, and then multiply the outside with its reciprocal. Plus the integral u to the half is u to the 3 halves, and then becomes 2/3. And since we're integrating indefinitely, it's plus c. Cross out the 2's, this becomes a 1/5. 1/5 u to the 5 halves plus 2/3 u to the 3 halves plus c. And finally, whatever u was, replace it back in. 2x minus 1 to the 5 halves all over 5, and plus 2 times 2x minus 1 to the 3 halves all over 3 plus c. And there's your answer. So this is a different kind of u substitution. Well, it's not even u sub anymore. It's actually just like x sub. So, well, it is part of u sub also. So it's like x u sub. So, next example. So this time we have x on top and the square root of 2x minus 1 on the bottom. So let u equal 2x minus 1. And then when we solve for x, x is going to equal, like the previous problem, u plus 1 over 2. So for every x gets replaced with a u plus 1 over 2. So it's going to be the integral, and this time we're doing definite integration, the integral from 1 to 5 of x, which is now u plus 1 over 2, all over the square root of 2u plus 1 over 2 minus 1 du. And we already know what this equals to. This inside of the radical, we know that it's going to be a simple u. So it's going to be 1 to 5 of u plus 1 over 2 times a 1 over the square root of u, which is the same thing as what we just said right here. Okay. Now, you guys probably already think, okay, well, sir, why did we do all this work inside here when 2x minus 1 is already u, and this is u? Well, you guys know the way I am. I like to make things complicated. So, let's continue. The 1/2 can go up here on the outside of the trig. I'm sorry, the outside of the integral. 1/2 integral of 1 to the 5, 1 to 5 of u to the half, I'm sorry, u plus 1 times a u to the negative 1/2 times u. And let me go ahead and change these limits of integration since I want to do it using the method number 2 way. So if I plug in u, if I plug in 5 for x, I get 9 when I plug in 5. When I plug in 1, I get 1. So let me change these limits of integration. Since we're doing everything in terms of u, it's going to be 9 and 1. Let's continue. Distribute the negative u to the half. A u times a negative, a u times a u to the negative half is a u to the half plus u to the negative half du. Almost done. Now we can integrate. We haven't integrated yet, but now we can. A u to the half becomes a u to the 3/2 times 2/3 plus a negative u to the half becomes a u to the positive half times 2. Since we're integrating definitely, it's going to be from 1 to 9. So let's make some cancellations first. If I distribute this 1/2, that goes away. If I distribute this 1/2 here, that goes away. So this becomes 1/3 u to the 3/2 plus u to the half from 1 to 9. And then we can go ahead and use our FTC here. 1/3 u to the 3/2, 9 to the 3/2 minus, no, plus 9 to the half, and then it's 1/3 1 to the 3/2 plus 1 to the half. What is 9 to the 3/2? That is the square root of 9 times to the raised to the third. So that is 27, and then a third of 27 gives you 9. So this becomes 9. What is the square root of 9? 3. 1 to any power is 1 times the negative third is negative 1/3, and then 1 to any power is 1. Distribute the negative, it's minus 1. This is 12 minus 1. This becomes 11 minus a third, which is 33 over 3 minus a third. And your final answer is 30 over 3. Sweet. That was pretty easy. Okay. Now, next problem. And then we're done with this lesson. So, in this problem, we're going to let u equal x plus 1. So, u minus 1 is equal to x. So let's go ahead and make our substitutions here. For every x is a u minus 1, so it's going to be the integral u minus 1 all over the cube root of u. I'm not going to rewrite the limits of integration. I'm going to change them by plugging in my 7 and 0. So u of 7, if I plug in 7 into my u function, it's 8. If I plug in 0 into my u function, it's negative 1. Okay, so it's from negative 1 to 8. Let's rewrite this integral from negative 1 to 8 of u minus 1 times u to the negative 1/3. du. Distribute and distribute. A u times a negative times a u to the negative 1/3 becomes a u to the positive 2/3, because you're taking a whole u and you're taking 1/3 from a whole, so you're left with 2/3. And this becomes u to the negative 1/3 du. And now we can integrate this. And we even have our limits of integration changed. So let's do so. U to the 2/3 will become a 5/3 u times 3 over 5 minus u to the 2/3 times 3/2. And we're doing definite integration, so it's from 1 to 8. So let's go ahead and apply it. 3 over 5 times 8 to the 5/3 minus 3 over 2 times 8 to the 2/3. And then 3 over 5 times, wait, it's negative 1. Keep on. So that's negative 1, guys, right here. I forgot to write negative 1. 5 to the negative 1 to the 5/3 minus 3 over 2 negative 1 to the 2/3. So what is 8 to the 5/3? Let's take the cube root. What is the cube root of 8? Cube root of 8 is 2 raised to the 5th. That is 32. What is the cube root of 8? Cube root of 8 is 2, and then when you square it, that is 4. Okay, what is the cube root of a negative 1? That's cube root of negative 1 is negative 1 raised to the 5th. It's still a negative 1. But when you have a negative times a negative, you get a positive, so it's a positive 3 over 5. Cube root of negative 1 raised to the 2nd is a positive number, but the negative here times the negative here will make it into another negative. So you have triple negative. You have a positive, because this became positive. You had a negative here times a negative, it's still positive. So it's 3/2. So let's do this very, very carefully. Let's do the easy part first. 3 times 32 is a 96 over 5 minus, this becomes a 2, so it's a negative 6 plus 5/3. No, not 5/3, other way around. 3 over 5 plus a 3 over 2. Let's go ahead and add these two. 99 over 5 minus, let's do plus 3 over 2 minus 6. Okay, so let's find a common denominator here. In fact, you know what? Let's go ahead and change this 6. I should have probably just left it like this. Let me go back. Messed up. Okay. All right. So let's go ahead and multiply these two as 12 over 2, which is the same thing as 6. 12 over 2. 12 over 2 is the same thing as 6. So that when I have these two combined, this becomes 99 over 5 plus, well, not plus anymore. Now it's a negative 9 over 2. And then let's find a common denominator. Multiply top and bottom by 2, not 5, 2. 2, 2, this one is 5 times 5. So this becomes a minus 45 over 10. This becomes a 198 over 10. And now I can go ahead and subtract 153 over 10. And we know that is our area. Okay, so there is the second kind of use substitution. It only comes out every once in a while in an exam. If it does come out, it'll probably be like one problem, maybe two at the most, but it's not very often these are asked. But at least you guys are prepared. Now that you guys have seen this, practice it.